Okay, so let's look at a tricky example. You should see on your screen the following equation. The absolute value of 3x minus 4 is equal to the absolute value of 5x plus 12. Now, remember from class that we said that if we had the following, the absolute value of x is equal to 7, then either x is equal to a positive 7 or x is equal to a negative 7. Because remember, absolute value just turns whatever the number is. If it's negative or positive, it turns it into a positive. Let's think of it like that. So if we have the absolute value of 3x minus 4 is equal to the absolute value of 5x plus 12, then either 3x minus 4, which would be like the x in this case, so either 3x minus 4 is equal to a positive 5x plus 12, which would be like the 7 in the example, or 3x minus 4 is equal to a negative 5x plus 12. So looking at this, you can see that the expression on the left, nothing happens to that one. But the expression on the right, you're going to solve two equations, one with a positive version of that expression and then the other with a negative version of that expression. So let's solve both of those equations. So first we'll do the either. So you're going to have 3x minus 4 is equal to 5x plus 12. As you know, you're going to group the like terms. Now, I know that you were traditionally taught that if you've got positive 12, then you're going to minus 12. But it's going to be easier for you to think of kind of like moving it across. So, and I'll keep doing it both ways until, I start doing it only this way. So you will have 3x minus 4 is equal to 5x plus 12, like I said before, and you're going to move the 12 over to the left and the 3x over to the right. When I do that, the 3x becomes negative and the 12 becomes negative as well because they were both positive. So I'm going to end up with negative 4 minus 12 is equal to 5x minus 3x, and that's what you have in line 2. Simplifying, I'll get negative 16 is equal to 2x, as you see in line 3. Then, to solve for x, negative 16 over 2 is equal to x, because I'm going to divide by both sides by 2. That's what you have in line 4. And then, x is going to be equal to negative 8. Now, I also wrote it down as if the way that you're used to, just to show you that you're going to get the same answers. So 3x minus 4 is equal to 5x plus 12. I subtract 12 first on both sides, and I end up with 3x minus 4 minus 12 is equal to 5x plus 12 minus 12. The positive 12 and negative 12, those two cancel out because they're additive inverses of each other using the additive identity property. If I add a negative number to a positive number, a positive version of that same number, I'm going to end up with 0. Additive identity property. So you have, now you simplify. So, you're going to get rid of the positive 12. So you end up with 3x minus 4 minus 12 is equal to 5x, which is in line 3A. Then you will have, I'll get rid of the 3x now. So 3x minus 4 minus 12 is equal to 5x minus 3x. I just haven't simplified yet. Again, that cancels out. So you'll end up with minus 4 minus 12 is equal to 5x minus 3x. And that's in line 5. Then minus 16 is equal to 2x. I've simplified here, because negative 4 minus 12 is going to give you a negative 16. And then I'm going to divide both sides by 2, and I will end up with x being equal to negative 8, just as before. Now let's look at the OR. So the other option, which is that 3x minus 4 is equal to a negative what was in that absolute value, which is the 5x plus 12. I have to distribute. Remember in math, just like you see here in line 1, again, at bottom, you will see if there is no number in math, typically you assign a 1. Okay, so now I need to distribute that 1 to the terms within the brackets, within the parentheses. So I'll end up with 3x minus 4 is equal to negative 5x minus 12. And now I've got to move these over, as you can see in line 2. I'll move the negative 4 over, and I'll move the negative 5x over to that side. Now you could do it the way that we did it before, with moving the negative 12 and the 3x. I just try to move it so that I have a positive coefficient in front of my x. And these are just habits that I've developed over the years. It doesn't mean that you have to do it that way, because any way you do it, you will get the right answer, as long as you haven't made a mistake somewhere. All right, so in line 3, I end up with 3x plus 5x is equal to 4. 4 becomes positive, minus 12. I'll have 8x is equal to negative 8. Now x is equal to negative 8 divided by 8. And now x is equal to negative 1. So I've got my two solutions here. X is equal to negative 1 and x is equal to negative 8. And I'm going to put them in a set. Remember, for equations, you don't use the typical set interval notation. You're going to use a set, a raster method set. And this set has only 2 elements because only 2 numbers satisfy this equation. So I'll have negative 8 comma negative 1. Negative 8 is on the left because it is the minimum value. Remember, negative 8 is less than negative 1. And negative 1 goes on the right because it's the maximum value. And then you have these set braces. And that's your final answer.